Hello everyone and welcome back to our channel Quaint Questions. Today's discussion is quantum threat to HTTPS. Will the web stay secure? Yes, this is the title of this video. So suppose when you visit a bank's website or send a message over WhatsApp, that little padlock icon near the HTTPS silently promises you one thing: security. Your data is safe, your messages are private, and no hacker can read or modify them. But there's a shocking truth. Quantum computers might soon shatter that promise. Yes, this is the shocking truth. Quantum computers might soon shatter that promise. You know, actually what? Actually, this HTTPS, you know this thing, relies on encryption. Okay, that means what? It's a way to log data so that only the intended receiver can unlock it. When you type https://www.yourbank.com, okay, then what happens actually? Your browser performs a TLS handshake with the bank server, and this handshake uses public key cryptography, mainly RSA or elliptic curve algorithms. The public key is shared with everyone, and the private key that is kept secret by the server, means by the bank server. Okay, and together they ensure that even if someone intercepts the data, it's a meaningless device. So for few decades actually, depending on these mathematical problems, encryption techniques were developed. Okay, encryption techniques like RSA, then elliptic curve algorithms, those things rely on actually mathematical problems. And those things actually worked beautifully for decades. But now there is a problem with quantum computers. And this is nothing but the disruptor. To what? Disruptor to these existing encryption methods. You know, classical computers use zeros and ones, and they actually means operations are performed sequentially. But in case of quantum computers, they also use 0 and 1, but those are known as qubits, because in that case 0 and 1 can exist simultaneously. So we should thank to superposition. And so what happens in this case of quantum computing? Actually, you can use, means users of quantum computers can test enormous combinations of keys in parallel. Means actually quantum computers allow you to test enormous combinations of keys in parallel. And you know that in the year 1994, Peter Shor discovered an algorithm which is famously known as Shor's algorithm. And if you perform that Shor's algorithm on a quantum computer, then what happens? You can easily factorize large numbers. Within few seconds or minutes. And you know that today's encryption methods or techniques rely on this thing, that is factoring very large numbers, since it is very hard for the classical computers to factorize large numbers. Not only very hard, I should rather say that actually those large numbers, means if you want to factorize those large numbers using classical computers, these classical computers would take millions or billions of years. But the same thing could be cracked by using quantum computers within just seconds or minutes. That is the problem. That's why we are talking about quantum threat to HTTPS. That means threat to HTTPS by the use of quantum computers. That is the threat. So by using quantum computers, hackers can easily break today's encryption methods. So scientists are not actually sitting idle. They are not waiting for the disaster. They have already started designing designing quantum resistant algorithms, and collectively those things are known as the post-quantum cryptography, or in short PQC. Like lattice-based cryptography, hash-based signatures, then multivariate polynomial equations, and all these things also rely on mathematical problems. But quantum computers, if you use quantum computers to solve these problems, then also in that case these mathematical problems are so complex that even quantum computers must struggle. Means that quantum computers cannot solve these mathematical problems efficiently. So these mathematical problems have been chosen for the development of new cryptographic techniques. That means what? That means in the future HTTPS will evolve with new cryptographic protocols. For what? To resist quantum attacks. To resist quantum attacks. And very often this is known as what? Known as post-quantum HTTPS or quantum safe TLS. Okay, and there is one example, I have already posted a video on that thing, CRYSTALS-Dilithium. This is known as actually post-quantum digital signature standard. That means actually NIST, the US National Institute of Standards and Technology, they have declared this thing, CRYSTALS-Dilithium, as the post-quantum digital signature standard. CRYSTALS-Dilithium. Okay, just 2 to 3 days back this video was posted on the same channel. You can watch that video. Anyway, so you can see what? You can see that HTTPS is evolving. Scientists are not sitting idle. They are not waiting for the disaster. They have already started working on this problem, this threat. Though by using today's quantum computer cannot break. Quantum computers are existing. You cannot find widespread use of quantum computers at present, but they are existing. But using those quantum computers, you cannot break today's encryption techniques or algorithms like RSA 2048. Okay. Because today's quantum computers are using only few hundred qubits. But what is the requirement to break today's encryption method? Millions qubits are required. Okay, millions of qubits are required for the quantum computers to break today's encryption methods. But in near future, we are expecting, or better to say scientists are expecting that they will develop such quantum computers which would use millions of qubits at the same time. So by using those computers, today's encryption methods actually must fail. Means those quantum computers could easily be used to break today's encryption methods, and that's why scientists are working on this issue, on this problem. Anyway, so this was all about today's topic. So there was a question in the title. Okay, what is the answer to that question? Scientists are working on this, so we can easily expect that, and already there is some progression in this field, so we can say that yes, we will remain safe, means our web will remain safe, our HTTPS will remain safe by using new cryptographic techniques. Okay, we can expect this thing, okay? It is not guaranteed. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video fascinating, so please like, share, and subscribe to our channel. This is the end. Thanks for watching.